Hello, and welcome to another edition of Containers from the Couch. I'm your host, Jeremy Cowan, and with me today are Justin, over there. I always get confused
I
about
know,
the
it's always
orientation of
backwards.
the screens.
Always backwards.
Yeah, so Justin is joining us today, as are Alex and Todd. Alex, you want to introduce yourself and say what you do here at AWS?
Yeah, sure. So my name is Alex Kestner, and I'm a product manager on the Amazon Elastic Kubernetes Service team. Specifically, I focus on all of the worker compute products and features that you can use with EKS. So, for example, EKS managed node groups, EKS Fargate, the EKS optimized dummies, and last, I think the topic for today is Carpenter. And so I work with Todd and a bunch of really talented folks on the Carpenter project here at EKS.
Great. And Todd, how about you? What's your role at AWS?
My name is Todd Neal. I work here at AWS, specifically on the EKS team, and for the past 6 months or so, focusing on Carpenter. Specifically, a lot of work on scheduling, ensuring correctness, and then lately consolidation.
Great. And I want to extend a warm welcome to the folks who are joining us live on the stream today. If you happen to be live and want to say where you're calling in from or accessing the stream from, feel free to post a message into the chat. And as Alex and Todd mentioned already, hey Bob, as they mentioned, they both work on Carpenter, and that's going to be the focus of our conversation today. And so I was wondering if we could begin by Alex having you give us a quick overview of Carpenter. I know it's a groupless autoscaler, but can you explain to the audience what that really means?
Yeah, no, absolutely. And I think that I'll even take a step back further and just talk about at a very high level autoscaling in Kubernetes. For those that maybe aren't familiar, I'm sure this is kind of a rehash for most folks tuning into the stream today. But there's kind of two types of autoscaling in Kubernetes. One would be pod-based autoscaling, so where you're either increasing the number of pods or the resource requests within them. And then there's cluster autoscaling, which adds new compute capacity to a cluster as those pods scale and require more resources of the cluster itself. So want to be very clear here about where Carpenter fits into this landscape, in that Carpenter is a cluster autoscaler. So it will respond to the changes in the pods that are in a cluster and add new compute resources as necessary based on their individual needs. So you mentioned the Kubernetes cluster autoscaler, which has been kind of the de facto way for autoscaling clusters, for quite some time. And with Carpenter, we decided to take a bit of a new approach. And I think that you alluded to this with calling it a groupless autoscaler. And I think that's definitely one aspect to it. It's also, I think, a little bit limiting in that Carpenter also handles some node provisioning and lifecycle management operations as well. So one really good way to think about what Carpenter is and how maybe it's different or similar in some cases to the cluster autoscalers is to walk through those kind of the comparison. So it's similar to the cluster autoscaler in that it looks at pending pods that are unschedulable as the signal as to whether or not it should add compute capacity to a cluster. Differs though from the cluster autoscaler that it looks at all of the resource requirements of those pods and launches the best fit compute resource to the needs of those workloads as they're coming into the cluster. So instead of having static groups of predefined compute types, Carpenter will leverage the full breadth of the compute options available to you and pick the best fit one that it can for the workloads that are coming in. Similar to the cluster autoscaler, as those workloads scale down or are removed from the cluster, it'll remove capacity as needed to keep your cluster running running without too much overhead. I think different from the cluster autoscaler, and this is something I think we'll spend a bit of time talking about later. It'll also look for opportunities to reschedule workloads to improve the utilization of your cluster overall. There's a new feature we've just released calling it Consolidation, and we'll be getting into it in much more detail later. But I think at a high level, that's kind of the key thing to keep in mind with Carpenter. Really pays attention and is very integrated into both Kubernetes as well as your cloud provider to make sure that the compute that gets launched to support the workloads in your cluster is as well suited to it as possible.
Great. So I know it's a very fast-moving project. There have been about 60 or so releases since its inception, which is a lot. And we haven't had a session like this for Carpenter in a while. So I was wondering if you could tell us a little about the features that we've released recently that the audience should be aware of.
Yeah, I mean, I'll be honest. I think I'm going to have trouble covering everything that we've done since we last spoke, which I think was probably last fall or earlier this year. And you're right, the project's moving really quick. It's an exciting time. There's a lot of new features being added, improvements to the project being made all the time. We've been really trying to do our best to keep to a weekly release cadence, which allows us to bring out all these features as quickly as we can, so that folks can take advantage of them. I think there's sort of two categories that I'd put some of the more recent releases into. The first, and these are sort of a little further back, so a few months ago rather than more recently, but are about reducing the configuration that's required to use Carpenter. And so this means both the configuration you may need to apply to the compute that provisions, as well as to Carpenter itself. So one of the things that we launched earlier this year was a new CRD for Carpenter called an Aws Node Template. And this allows you to specify custom AMIs and even user data within Carpenter CRDs directly, instead of having to go to a custom launch template and specify those in another layer of configuration to get those benefits to the compute that Carpenter provisions. I think similarly, there's a really rich semantic in Kubernetes around label selectors. This in, not in sort of language is really powerful. And so we've added a handful of well-known labels so that customers can more simply and flexibly select the compute that they want Carpenter provision. They may have a variety of requirements about, and for different workloads in a cluster as well, that they'll want Carpenter to provision compute for. And so we made it a lot easier for them to specify those requirements within Carpenter using Kubernetes native semantics, which is kind of a key goal for the project. Mm-hmm. I know earlier this year, and this maybe came out just after we last spoke, but a lot of existing workloads and third-party tools leverage interpod affinity and anti-affinity for ensuring availability for these workloads, so spreading pods away from each other or grouping them in some cases. And this is kind of a tricky knot that we had to untie with the project earlier this year. And so happy to say that as of this spring, pod affinity and anti-affinity are fully supported scheduling constructs in Carpenter.
Nice.
So those are kind of all of the simplicity and ease of use features that we built in Carpenter in the last few months. I think the other category here is a really exciting one for us on the team, I think for customers as well, which is around how Carpenter can help improve the cost efficiency of clusters. Managing the compute in a cluster, especially very large ones, can be very challenging, if not impossible in some scenarios. And so we wanted to see how we could build features into Carpenter that would automatically, take advantage of opportunities to look for ways to improve the cost efficiency of the cluster's compute. So first, one of these features is called weighted provisioners. So Carpenter has a couple of CRDs. We mentioned the AWS Node Template earlier. The provisioner CRD is kind of the main configuration object for the project. And oftentimes customers will want to specify multiple provisioners in a single cluster because they have different kinds of compute scenarios that they want to be able to have Carpenter handle. One use case here, for example, would be that perhaps you have reserved instances or savings plans from your cloud provider, AWS in this case as well. And you want to make sure that you get the best value out of those commitments that you've made. And so you want Carpenter to provision those kinds of compute first. And so you could perhaps say, always provision the instance types that are covered under my my savings plan. And then when maybe I don't have any left, we can move on to provisioning more broadly across all of the compute that's available from EC2. And then finally, I think
I'm sorry.
Yeah.
How would you indicate how many, say, reserved instances you have? Is there a way to specify that in the provisioner?
So the way that you would do this is you'd specify a limit on the provisioner, saying that don't provision more than this much compute or this much memory using this provisioner, and then afterwards, move on. So this is one of the mechanisms that we built into Carpenter early on in the project to allow customers to control how much compute Carpenter would provision, and it serves the purpose of allowing customers to shift over to a secondary provisioner pretty well in this use case.
Nice.
Yeah. And then the second one, and this has been a major feature for us, one that we're really excited about, is called consolidation. This is a pretty major improvement to the project. It was one that we originally thought would be a core part of the vision for the project in the long term. We initially focused on kind of the scale out performance and use case of Carpenter, but earlier this year we were able to start to tackle this kind of very challenging problem of how to optimally reorganize the workloads in a cluster to improve utilization and make clusters more cost efficient. I think these, that's a big list of features, like you said, Jeremy, that the project's moving really quick, and there's always more coming down the pipe, which I'm sure we'll get to a little bit later. But I think those are the ones that I'd highlight in terms of really exciting new features for Carpenter that I'd mentioned today.
Yeah. So, I mean, along with better resource utilization of your compute, do we have estimates as to the amount that customers can potentially save by enabling consolidation?
It's a great question, and one that I can't say sort of definitively one way or the other, because customers' environments vary so dramatically. I can say this, though, in our experience and from the feedback that we've gotten publicly from Carpenter customers through, for example, our Carpenter channel on the Kubernetes Slack, there's kind of two main ways that we see customers improving the cost efficiency of their clusters with Carpenter. The first is simply by using Carpenter to begin with. The choices that it makes about the kinds of compute that it spins up compared to other solutions tend to be more optimized and more efficient than if you were to choose from a small number of predefined kind of buckets of compute. So that's definitely kind of the first way that we see customers improving their cost efficiency with Carpenter. The second is by turning on consolidation. If you could scroll back in through the Slack history in that channel and see that some folks see improvements. Somebody posted a screenshot that we were really, really happy about that showed them going from about a 40% utilization before enabling consolidation. It was all kind of very steady at 40%. Enabled it, and we're able to see improvements of their CPU utilization going up above 80%. And so I want to stress, this will vary pretty significantly from environment to environment and customer to customer, but there are, I think, major gains to be had with Carpenter overall and consolidation specifically.
Great. Well, I think we're ready for the demo. No episode of Containers from the Couch would be complete without a demo. So Todd, if we're ready to transition to that, let's have a look.
All right, sure thing. So as Alex was talking about, some of the new features in Carpenter, I'm going to show you the provisioner that I'm using today, and it's going to actually use some of those new features. So this is my default provisioner. I've got two in my cluster currently, but this one is weighted with a weight of 50, which happens to be the highest. So Carpenter is going to prefer to use this provisioner first, and it will only use the lower weighted provisioner if this one fails for some reason. If I hit a limit or for some reason it can't actually provision a node that works. You can see I've got consolidation enabled. Some of the labels that Alex was talking about, there's an instance family label now on the nodes. So I'm just telling my provisioner, hey, I don't want any A1, C1, C3, or INF1 nodes. So anything those entire families are excluded. This one is kind of neat. All the nodes are labeled with their CPU type or CPU counts. And at first it kind of sounds a little bit strange because the CPU is also represented in the resources. But with the greater than and less than operators, this actually lets you select for nodes that sort of fit the shape that you want. So you can say, I don't want any super large nodes, no 48XLs or anything like that. So in this particular example, I'm selecting for instance types that have 32 CPUs or lower. And I'm doing on-demand nodes only and AMD 64. You'll notice that there's nothing in here that's AWS specific. This is all just generic cloud provider stuff, and it could work with any cloud provider. Here at the provider,
yeah, this is nice. because I think when Carpenter was first released, you had to specify the instance types that you wanted it to use when it needed to provision additional compute. And now you can specify whole families of instance types.
Yeah, so previously it would normally use every instance type, but if you wanted to just select a few or select a family, you had to go in there and list every one in the entire family, every size. And customers let us know, that works, but that's not super nice to be able to do. So being able to select or exclude, include or exclude families just makes for a sort of a much easier to maintain provisioner.
That's great.
The provider ref here, you see I'm actually referencing an AWS Node template called default, and this is where all the cloud provider specific information is at. So I will go open up that one. If I can find it. And now we get to the AWS specific information. This is my default template. I'm actually selecting an AWS ID for the AMI. So you can select AMIs by tags or by ID specifically. And this is something that's new to Carpenter. Previously, you would have to create a launch template and actually configure it there. But now you can actually just specify your AMI ID right here. Also, user data. You can add your own custom user data, either for the AL2 or the Bottle Rocket family. And for the AL2, it says a MIME shell script basically that gets run just before the bootstrap. For Bottle Rocket, it's in TOML, and it gets merged in with the TOML config that's used for the Bottle Rocket nodes. So, and then for custom, it's just the custom user data. But basically, between the ability to select AMIs and provide your own custom user data, it should eliminate most of the cases where you would ever need to construct your own custom launch template, and you can just sort of handle it directly within Carpenter.
Nice, and I like how you don't have to base 64 encode your user data.
Yes, there were several iterations here of trying to find the best user experience for this, and this is kind of what we settled on for now. So.
Nice.
And now we'll switch to my cluster. So just to orient what we're looking at here, these are all of the Carpenter provision nodes. I have 8 nodes in my cluster, and those nodes have a total of 254.8 allocatable CPU, and 249.8 of them are requested based off of these pods. And the overall CPU utilization is 98%. And that is CPU request utilization. So that is the amount of CPU requested by the pods. It's not actually CPU that's being in use by the pods. And Carpenter works across all of the resources, so CPU, memory, ephemeral storage, and everything. But for this demo, I'm just showing CPU because it's a little easier to think in just one dimension. So I've got 1,000 pods in my cluster. 0 of them are pending, 1,000 of them are running, and 1,000 of them are bound. And here are my 8 nodes. And you can see that they're pretty much all utilized. Most of them have 120-ish pods. They're all C6A 8X largest at $1.22 per hour, and they're all ready. So I'm just going to scale my deployment down, and we'll rapidly see some pods start disappearing. So what's happening now is my overall cluster utilization is dropping because some pods have been removed. Consolidation actually already kicked in and removed a node. But as that node's been removed, we'll see the pods go back to pending, and then we'll see consolidation start to kick in again. Now, right now, before consolidation, Carpenter would actually just stop here. We would be at 78.5% utilization. And since there's no empty nodes, that's the best Carpenter would previously do. But now Carpenter's recognized that this node's actually not needed. So it's slowly draining this node. It's coordinated and it's draining the node. The pods are being moved to other nodes within the cluster, and we'll eventually see our CPU utilization rise above 78.5. Over here, if we look at the pending pod counts, we'll see that it never actually gets above 5. And that's because I have a PDB that's controlling the rate that these pods are being evicted. But for demo purposes, I can actually just get rid of that. And that will make the consolidation process faster. Nice. So now it will evict all the pods on the node all at once.
Yeah, so I see that there's a question here from MDK194 that says, what tool is used to show node utilization? This information that you're showing now is available in a Grafana dashboard, is it not?
Yes. Yeah, there's a Grafana dashboard that's covered in the Getting Started guide that shows some of this information. This is a custom tool I built just for demoing consolidation. So it's not actually made available yet, but we can look at doing that.
I had a couple of other questions that I wanted to interject here. So the first is around Node TTL and how that works with consolidation. When you reduce the pod count, I saw that a node had drained and it was removed. Do they work in concert, Node TTL and consolidation?
So there's two TTL values. There's the expiration TTL, which is your node has existed for this period of time, so we're going to remove it just to recycle the node. And then there's the emptiness TTL. So currently consolidation and emptiness TTL are mutually exclusive. Use one or the other. And it was kind of a decision made regarding that because it was sort of seemed odd if a node was empty to wait some period of time, but if it had one pod to act immediately. So kind of the user experience was a bit odd in that scenario. So that's sort of why it works that way. So currently I've done basically I've gone from 78.5% utilization back up to 91.5, and Carpenter's sort of paused at the moment. There's not much else it can do. But if we just reduce our pod count slightly, so I'm going to go from 700 to 640, and we'll just see if consolidation can figure out anything else to do. Previously, we saw it delete nodes. Looks like it's going to delete another node. Actually, no, it is replacing. That's good. So this is the second mechanism of consolidation. Carpenter has looked at this C6A 8x large. It's got 102 pods, and it's figured out that it can actually launch a T3 small and replace this 8x large with a T3 small. Now, obviously, these 102 pods won't fit on the T3 small, but between the available capacity on the rest of the cluster and the new capacity on this T3 small, those 102 pods will schedule. And if you look at the price here, we've replaced a node that's $1.22 per hour with a node that's 2 cents per hour.
Nice.
And this time period that's increasing here, that's the time since the node was created. So once it hits about 60 seconds, the node will get ready, and then we'll see Carpenter start to drain pods off of this node.
So
this is something.
Oh, sorry. Go ahead, Alex.
Well, what I was going to highlight is the fact that so in this custom tool here, the actual cost of the nodes is being shown, and it's not that that's like sort of something that is layered on top of Carpenter. It's actually fundamental to how consolidation works, in that we actually look at the cost of individual compute instance types to see what would the ideal decision be for consolidating the workloads in the cluster. There are some scenarios where you can imagine that the decision may be counterintuitive, but end up in an overall, more cost-efficient cluster. This is a lot of work that happened kind of under the hood as we were sort of setting up to build consolidation.
Yeah. Question on the utilization there, because you said this was based on requests for the pods, but not limits. And so if I have a pod that requested one CPU and then I do a bunch of work, what happens? What happens to my node if I'm at 100% of my requests are met? And let's say I have 5 or 127 of roughly the same stuff, and I get a big load and I need to use that CPU. What happens?
So for compressible resources like CPU, I think CPU is the only compressible resource, it will burst up to your limits. For the non-compressible, you can experience out-of-memory conditions. In our EKS best practices guide, there's some information there regarding for the most reliable behavior, you would set requests equal to limits for the non-compressible resources. But yeah, that is a consideration before you turn on consolidation. We've seen a few reports of customers experiencing pods that are all of a sudden failing readiness checks, readiness probes. And that's due to the request being too small, but you can sort of get away with it if your cluster is over provisioned. So, right? So if your requests are too small, but you have a bunch of excess CPU, you're fine usually. Now that Carpenter is actively trying to reduce your cluster cost and pack pods onto the fewest, cheapest nodes as possible, your requests are really important to ensure that you actually request enough CPU to allow your workloads to finish.
And I'm guessing at that point we recommend essentially using something like vertical pod autoscaler in recommendation mode to measure what requests and limits are actually being used in the cluster, not necessarily a Apache Bench or something on my laptop.
Mm-hmm. Yeah, there's some guides there, and it is challenging to, if you ask a developer how much CPU does your pod need, I don't know, give it 1 and we'll see how it goes. It's a challenging thing, but there are tools to simplify.
So I'm wondering what sort of churn consolidation may cause once it's enabled.
So I've just reduced the number of pods again just to watch it occur. Carpenter works by trying to identify the node that will disrupt your cluster the least that it can operate on. So in this case, it's probably going to take out this 47 pod node, which it just did, because that had the fewest pods. And if you can move those pods around, we'll disrupt your cluster the least. It follows PDBs. So if you want to control the rate that those workloads are evicted, you can apply PDBs to those. And also, during that node replacement case, you saw that we launched the replacement node before we started the drain. So we're trying to minimize the amount of time that we're waiting on a node to start up, and basically that there isn't enough capacity. So we do a few tricks like that just to ensure that we can get your workloads running back again as soon as possible. And again, Carpenter's figured out, hey, I can replace this C6A 8x large with a T3A 2x large. It's launching the T3A, and it's just waiting until it gets ready before we'll actually drain this 8x large node.
That kind of references a question that was asked earlier by, S. Thapa, about what people should consider in their clusters if they're moving from cluster autoscaler to Carpenter. What are the things that are important to have before doing something like that?
We've talked a lot about how Carpenter looks at the pod resource requests, various kinds of specifications for scheduling that the pods themselves will have and be taken into consideration. I think that seems to me to be one of the really key things to make sure that you have buttoned down as you start to look to Carpenter, is that the workloads themselves, and this could be done individually by individual application teams or by some kind of a controller, but you want to make sure that they're well specified so that any sort of requirements those applications may have are reflected in the pod spec for those workloads themselves, because that's Carpenter can't make decisions on information that it doesn't have. I think there's definitely ways to encode some cluster-wide best practices and guardrails through Carpenter provisioners, but the most effective way to leverage Carpenter is to ensure that all your workloads have as much detail about their needs as possible encoded into their pod specs. I think the other thing I'd mention, go ahead, sorry.
I was just saying, to your point, there's a lot of things people relied on just because it was the default. When I used a managed node group, that automatically got spread evenly across my AZs. When I used the Kubernetes scheduler, that automatically tried to best fit things across the nodes because all the nodes were the same size, and it more or less round robins my scheduling. And I got a lot of those high availability things because those were the defaults. In Carpenter, it's not the defaults. We're not saying high availability and spread is the default thing, so you need to be explicit about those things, because if you don't want those things, if you just want the fastest scaling possible, then a single node with the same image running 100 times is probably the fastest thing.
That's right. And PDBs are a great example of this too, whereas if you enable consolidation and you don't have appropriate PDBs set for these workloads, you may see a negative impact to their availability as they, as Carpenter tries to optimally pack the cluster and launching new nodes, et cetera. I think the other thing I'd mention is that you will need some compute in your cluster to run the Carpenter controller itself. We do see people doing this successfully on EKS Fargate serverless compute. You could use a self-managed EC2 instance, a managed node group, et cetera. That's kind of one other consideration I think I'd mention, is that there does need to be somewhere for Carpenter to run in the cluster.
I also saw in a recent release that Carpenter can now run in HA mode, where you can have 2 Carpenter instances. Is that right? And so if it's not a single pod, I can actually have 2 of them there, and only one of them will do the scaling.
Yeah, Todd, you want to speak a little bit about some of the changes we've made around the scheduling of Carpenter itself?
Yeah. So we've changed the default deployment. So Carpenter has always had or at least for a very long time. It's had leader election built in, so that it uses the controller runtime leader election to have only a single Carpenter controller that's actually provisioning. But yeah, we've updated the default so that sort of out of the box Carpenter works in HA mode, so that you have basically a backup Carpenter ready to take over the leader election and provision your nodes should there be some instance something happen with the node or with the controller itself.
And looks like there's another question here. Is there any future scope utilizing Carpenter for storage autoscaling?
Yeah, it's an interesting question that comes up, I'll say somewhat infrequently, but I do hear this kind of feedback on Carpenter. There is a GitHub issue that I can point the commenter towards. I'll find the link here momentarily as Todd gets back into the demo and share that. I think that if I was chatting with them now, I'd ask if they're curious about ephemeral storage, local to the instance, or EBS volumes, et cetera. All of those will have different kinds of considerations. So I'd be happy to share the feature requests that we do have on the GitHub repo today. I'll also take this opportunity to plug the GitHub repo itself. We are extremely active on the repository. Myself, Todd, the rest of the Carpenter team, and it's a great way to get in touch with us about a question like this. There's likely someone that's already kind of asked for feature requests that you may have, and so it'd be a great way to let us know what's important to you.
So Carpenter seems like a great way to improve your overall efficiency. Are there instances where consolidation shouldn't be enabled?
Yeah, there are a few cases. If your workloads are not resilient to disruptions, for example, and one example that may be a batch job that must run to completion, has no checkpointing, and if it gets restarted, you've lost all progress. So in that case, consolidation might actually cost you more money because you're letting it run for 2 days, and then 10 minutes before it finishes, the node gets replaced with a smaller one. The calculus gets a little more complicated. Mm-hmm. Some other cases, if you're doing, again, batch workloads, but you're using pod anti-affinity so that you get one pod per node, it won't necessarily hurt anything, but it probably won't help much either in that case. But yeah, there's a few specialized scenarios where consolidation may not be a great choice.
Is that also? I'm sorry. One quick thing about the storage, Alex. We have per AZ storage allocation now, right? So if my pod says I needed an EBS volume, which is only an AZ, we can match to a node in that AZ, which was a problem with cluster autoscaler sometimes because cluster autoscaler wouldn't match. My pod needs this EBS volume, so that's there right now, right?
That's right. That was actually one of the sort of first features that we added to Carpenter after its announcement at reInvent last fall. And this is something that just works out of the box with Carpenter. And it's a function of it being deeply integrated into Kubernetes as well as the cloud provider where you're provisioning these resources and is able to make sure that the compute that it launches will in fact meet the needs of the workload that it's meant for, including this kind of storage zonal affinity.
And to the second point about when consolidation shouldn't be used, Todd, it's a setting per provisioner, right? So if I have those batch jobs, if I have stateful sets or something I don't want disrupted, I can set a provisioner for those workloads and turn off consolidation so that those workloads will always be more stable or less utilized maybe, but I can still gain efficiency off of not having those disruptions. That's right.
Yeah, you can control it at the provisioner level or at the pod level. You can actually put an annotation on the pod and then prevent it from being evicted that way as well. So multiple levels.
So your demo here is one provisioner without that label, but you could create another workload and say, hey, don't consolidate this workload.
Mm-hmm. Yes, absolutely. And so I've got one provisioner here, and we spoke earlier about weighted provisioners, but I can show you my second provisioner. And this provisioner, it has a weight of 10, so it's been lower, so we haven't actually used it yet. But I can increase its weights. And the only difference between this one is that this provisioner actually allows ARM nodes to be provisioned. So Carpenter's at a steady state now. If we look, we're at 94.2% utilization. We have a couple of C6A, 8X, and 4X larges, and there's really not much else it can do. But by increasing the weights of that other provisioner that now allows ARM nodes to be selected as viable instance types, Carpenter should actually find some new consolidation options. And now it's determined that it's actually cheaper to replace this C6A 4x large with a C6G 4x large. So and it's kind of one of the things about Carpenter in general. The more flexible you are with respect to instance sizes and families and just everything about what you provision, the compute you provision, Carpenter is able to take advantage of that to reduce your cluster cost.
And so does that assume that you're using multi-architecture images?
Yes, that is one of that's a good call out. Yeah, a big caveat. The images I am running right now are multi-arch, so they'll work on either AIM64 or ARM64.
Okay, nice. So yet another way that you could potentially save money is by running your applications on lower cost compute.
Mm-hmm.
Nice. So I had another question here, really having to do with ECS and EKS. So for those folks who may have used ECS before, there's this concept of capacity providers where you can specify a ratio of like on-demand and spot instances. Is there a way to do that with Carpenter?
Yes, there are actually two different approaches, and there's a blog article somewhere that documents a way to use a mutating admission hook to basically do pod counts and apply the correct label selector or node selector to the pod to force it to go to the right spot or on-demand capacity type. And then there's another method that's documented on the Carpenter website, which it's kind of unique to Carpenter, but basically we kind of have a concept of virtual domains. So you can have multiple provisioners, one for spot and one for on-demand. And by assigning, you pick a label, say capacity spread, and you assign a certain number of values for that label to one provisioner, a certain number of values to the other, and that effectively constructs the ratio that you want to spread between capacity type or between spot and on-demand. It has some caveats that are called out in the documentation. It's not like a true spread across spot and on-demand in that ratio, but some customers are using it and they're happy with it, given the sort of the limitations that that we described there in the docs.
Nice, and that would give the ability to have uninterruptible instances alongside interruptible instances like spot for running your application. So you could always have, say, an instance of your application running on the on-demand instance, and then other replicas running on spot, so that your application is always available or not susceptible to interruption.
Yeah, so you can do like 20% on-demand, 80% spot. Mm-hmm.
Yeah, you can vary this, of course, by like environment. You may find that lower environments, like development environments, you want to be more heavy into spot than you would be in production, for example. I think though that one of the things that we touched on a moment ago was around this flexibility to compute. Todd was saying like the more flexible you can be, the more Carpenter is able to take advantage of that. And this applies, I think, most concretely to when you want to use spot compute in your cluster, because this is part of the sort of core spot best practices, is that the more flexible you can be across availability zones and instance families and types, the more likely it is that you're able to A, acquire spot capacity, and B, hold on to it for substantially longer than some of the more in-demand instance types and availability zones. This is, I think, another way that Carpenter, even from its launch, can help customers improve their cost efficiency in Kubernetes, in that by being very flexible to the kinds of instances that you may provision, you can often use spot more easily than you'd be able to previously.
Awesome. So what's next for Carpenter? I know that there may be certain things that we can't divulge, but what are we looking at big picture?
Yeah, so we've like you mentioned at the beginning of this, we've done a ton of work on the project since we announced its production readiness launch at reInvent last year, and so our main focus is moving the project towards a 1.0 release. We think that consolidation is sort of one of the last major features that we saw as a necessary prerequisite for 1.0, and there's a few more that I'll mention that are on the roadmap for us in the near future. So first, is a feature that will allow customers to more readily upgrade the nodes in their cluster. So for example, you want to either upgrade Kubernetes versions or the operating system, or packages in the operating system on your nodes. So you have a new AMI version that you need to roll out across your fleet. Right now, you can leverage things like the expiry TTL to over time gradually roll out new nodes with the new version of the AMI across all the nodes in your cluster. But there are times where you want to more directly upgrade all of the nodes, and so we're going to be adding a feature that will make it easier to do that. And that's kind of, I think, one of the most requested features on GitHub. And this is something that I think I definitely hammer home, and that when you upvote an issue on GitHub or ask for a feature request, weigh in with your use case, that's something that very directly influences what we work on. Similarly, we were just talking about how much easier Carpenter makes it to use Spot through EKS and Kubernetes. One of the sort of remaining, I think, gaps in terms of what Carpenter can take care of just on its own is handling notifications for acting on them when Spot's going to reclaim a node. Because with Spot, you can get a couple of different kinds of notifications saying, hey, this node is either likely to be taken away or will be going away in 2 minutes. And there's an existing tool called the node termination handler that you'd also have to run in conjunction with Carpenter in your cluster to have that full sort of lifecycle management. We're going to be folding in many of those capabilities into Carpenter itself, especially given, it just made sense to us given how much easier it is to use Spot. We might as well make it kind of the complete picture. And that'll be something that's coming soon. I think, the other thing we're really excited about is seeing Carpenter become supported in more environments. We'd love to see the community contribute additional cloud providers, or make it possible to use Carpenter in all the different environments that you may run Kubernetes clusters. And that'd be something that we'd really love to see before we cut a 1.0 release. But yeah, no, really just, I think that if there's a headline to the what's next question, is we're moving as quickly as we can towards a 1.0, and have been really excited by both the response to the project and by all the new features we've been able to add to it in the last 6 months or so.
And people may be excited about the things that they've heard here today and want to get involved. What's the best way for them to do that?
Yeah, so we have a few different ways that you can participate in the project. I think first and foremost, we mentioned the Carpenter channel in the Kubernetes Slack. That's a great way where we're all very actively participating in the discussion there. There's also emerging Carpenter experts from the community who will often pick up questions that other folks may have. Obviously, the GitHub repository is a great place to give us feedback on the project. If you run into an issue or you want Carpenter to do something more, cutting us an issue or a pull request, I suppose, as well, in case of an actual contribution, would be great. And then finally, we have a bi-weekly working group every other Thursday at 9 a.m. Pacific. So the next one of these will be next week. That's September 15th, 9 a.m. Pacific. And there's details about the video conference links and stuff, as well as I think notes from previous sessions in the GitHub repository. Those would be definitely the three ways I'd encourage folks to get involved in the project and learn more. We really love working with the community, and it's been such a great experience for us and the team. Great.
So those were really all the questions that I had. Oh, there's a question from Estapa again, or Stapa. Using Spot instances for multi-AZ workload, does Carpenter guarantee Spot instances are spread across AZs? Alex or Todd, you want to answer that?
I think that whenever I see the word guarantee and Spot in the same sentence, my spidey sense tingles. I think that the key thing to recognize with Spot is that it's effectively spare on-demand EC2 capacity. And so it's to the sense that it'll guarantee that there's Spot in every AZ. There simply may not be any Spot that'll meet the needs of your workload in a given availability zone, and that could definitely cause some challenges. I think the key thing is that if your workloads have requirements to be spread across multiple AZs and there is spot capacity available, Carpenter will take those requirements and provision compute that meets them.
Yeah, I think
as long as your requirements are in the workload.
Right.
I mean, that's the key part, right?
Yes.
Is the spread.
Yep.
That's right. You need to be intentional and flexible, right? You need to be intentional in your provisioners and your pod specifications, and you also need to be flexible, especially with Spot, because your Spot pool or the instance type that you're using in a particular availability zone, the pool that it was created from may be depleted, and so if you have greater flexibility as to the instance types that your application can run on, the less likely that there'll be no capacity available to provision the compute necessary to run your workload. Okay, awesome. Well, thank you for joining us today. Really appreciate it. Thanks, Alex. Thanks, Todd. Join us again for the next episode of Containers from the Couch, which I think is coming in a couple of weeks, if I'm not mistaken, about our partnership with KubeCost. So again, thanks for joining us, and we'll talk to you again soon.